Welcome to the Automation Insider. I'm your host, Joe McGrath from Hy-Tek Intralogistics. Today I have one of my good friends from AWL, Allart. Can you introduce yourself?
Yes, for sure. Allart from the Schootbrugge. I'm account manager for AWL. Basically working together with Hy-Tek for a couple of months now. So it's been a great journey, and happy to be here, Joe.
Yeah, thanks for having me. So I wanted to talk to you. I've been spending a bunch of time developing and designing beverage systems.
Yep.
So we're talking about cases of heavy liquids moving in and out. Sometimes they get sticky. Ideally, they don't break open. What is, I want to dig into what your process is for designing a robotic cell or designing a robotic process.
Yep.
When I can use really cool tools like AWL has.
Yeah, so of course it starts all with the product. So whenever we engage on a project, it's always looking at, hey, what type of products are we using? What type of products do we need to handle? And what type of products are we going to, let's say, pelletize or depelletize or whatever? So that's always where it starts. So we think from the product basically, and out of that we look at the process to see, hey, what kind of modules can we use and what kind of systems can we use to actually make that process work.
When you're talking about product, you're talking about like, it's 2 12-packs in an unwrapped tray, or it's some 2 liters in a shell, because like I think the handling characteristics are like really, really different.
Yeah, that's correct. That's correct. You're absolutely right there. And that's also where we think that some of that knowledge that you build up over time, you start using like cartons, because cartons is one of the first things that you engage with, right? And then at some point in time, you're like, hey, we see these stretch wrap kind of packages. Can we also handle that? Because it's a more difficult one than a carton. So, and then whenever a customer has like a certain palette of products, you can say like, hey, what type of ripping are we going to use? End of arm tools, etc. So from that perspective, looking at that side, you can start creating or concepting the machine around it. Okay. And of course, you were talking about throughputs and those kind of things. And in the end, also a bit about cost, but at first we need to have a technical process in place that can do the job.
So talk to me about like, what are the components kind of a robotic cell let's start with depalletizing.
Yeah.
If I have a huge pallet of beer and I want to take it apart as fast as possible.
Yeah.
What are the different pieces of that system that I need to be aware of?
Yeah. So as we say with AWL, everything starts with the robot, because that's where the magic happens, right? But the robot cannot do it alone. And especially if you look at robotics from history, they're very good at doing the same thing over and over again.
Yeah.
And that's one of the things we saw like 5 years ago. Hey, we see a development going on, like in camera technology, AI vision. It was quite nifty at the time, I would say.
Nifty.
Yeah. Is that a good word, nifty?
It's a great word. Yeah.
Cool. Awesome.
Yeah.
And so we thought, hey, there's an opening there for us to jump in, because we are not the ones to figure out, let's say, the next single SKU pelletizer for like a small amount of money, because that's already there for a long time.
Yeah.
A lot of people do it, so we could not be competitive there. So we said, let's see if we can use AI to, and I know it's a bit of a buzzword, AI, right? Everybody uses it now, but let's see if we can use it to give the robot his eyes and the brains to do something not the same time every time.
Yeah.
So that's where you see like the robot giving the camera and the brains. That actually gives the possibility for the robot to do stuff randomly.
Yep.
So you get a situation, you make a picture out of it, and together with the AI, you decide, hey, what is the best approach to pick the case or a unit with all bottles?
Yeah.
So those are, let's say, the main components. And then around it is, of course, where you are very good at. How do I get the pallet to the robot? Because the robot has a certain reach.
Yep.
And you need to be inside that reach to be able to actually...
Yeah, the whole sphere of influence of that robot.
Yeah, correct. Yeah. And it's quite strict where it goes.
Yeah.
And where it doesn't go.
Yeah. Or where it shouldn't go.
Or shouldn't go, yeah. So, well, good that you say it, because for safety, one very important topic, the robot should not be able to harm anyone. So safety fencing, safety light screens, those kind of things, all has to be interconnected together with the robot and the controls to make sure that that's working safely.
I think the safety thing is interesting. Like, we get a lot of questions about like a cobot, right? Versus not.
Yeah.
And a lot of the systems I put in, it's not a cobot.
Yeah.
And that's for a very good reasons. You want to hash that out a little bit?
Yeah, I think a cobot is, I mean, it sounds very nice. Yeah, robots working together with humans.
It's a beautiful vision.
It's a beautiful vision. But if you're looking at business cases and throughput and speed, a cobot can also be unsafe.
Yeah.
If you use it on full speed, it's just as dangerous as a normal industrial robot.
Yep.
So you have to take safety measures to make sure that whenever somebody's around, that it goes to cobalt mode. And then again, then it's like, it's just a slow industrial robot.
Yeah.
For us, we've seen multiple use cases where somebody said, no, I want a cobalt because I want to work it alongside with humans. And then if you start looking at business case versus throughput, etc., most of the times you end up with an industrial robot with safety fence around it because it just gets the job done better. And I know we have some partners here around. They make great cobalts. And I think the market there is also progressing. So you see some cobalt applications with palletizing and depalletizing. So very nice and also curious to see what the future will bring us over there.
Yeah, so using a cobot is super context specific. Like everything has to be right. And most of the time, and this is my experience too, even with like not just arms, but like AMRs and stuff like that. Can I just put them in a field, lock it up, and make it go real fast?
Yeah,
like that's
correct.
People are very okay with that.
Yeah.
Great payback,
Yeah, and that's also, if you look at our machine concepts, sometimes you would have like a standalone machine where you feed pellets in from one side and feed them out at the other side. But then you can also make it safe because basically you have a big hole in the machine.
Yep.
But you have to feed where you have to feed the pellets through. But with the current safety hardware that's available, you have a very good system, a very safe system that can actually make that work.
Yeah.
So it's depending on the environment as well. I mean, if you guys build a complete warehouse and you don't have the possibility to create the big fence around it, we always have a possibility to not do that and make something different, right?
Okay. What other components did we miss here? So we have a camera that sits over the top of it.
Yep.
And you guys are connecting that to an AI.
Yep.
But it's not just one AI. You guys work with multiple AIs, or what's that ecosystem look like?
Yeah. So the strategy we follow is a partnership strategy. So we have decided not to go for AI ourselves. So we could say, let's take 75% of our R&D budget and put it in AI.
Yeah.
We could have done that, but we decided not to because there are people in the market that are very good at that and have a very
all they do, 100% of their budget.
100% what they do. And we said, let's see if we can leverage that together with them to see how we can integrate it with our machines and make sure that 1 and 1 is 3.
Yeah.
So that's what we do, to say to all these great partners out there, hey, what is your system capable of? And a lot of people say like, yeah, we can do XYZ. And we're like, okay, come to our experience center. We'll benchmark it. We'll test it. We'll see if it's actually doing what you prove or what you promise. And if it's any good, we're happy to integrate it.
Yeah.
So for us, that's also where we say we need to be flexible to use those systems, let's say, with different use cases. And so what we did, we created software which we basically can plug into and say, okay, now we use system X, now we use system Y or system Z.
So different AI like packages are good at different things. Is that kind of the flavor?
Yeah. That's correct.
So give me, you don't have to use any names, but give me some examples. Like what could one AI be good at that another one like maybe doesn't excel at?
For instance, there's always a picking to from, let's say, from many to a single, or you have from single to many, from one SKU to a pallet. And some are better in, let's say, building a pallet, and some are better in just picking out of a bulk of parcels, for instance.
Okay, yeah, the random stack.
Yeah,
that's the problem.
I mean, and if you look at your industry where you get a pallet of, I don't know what, bottles or cases, there are systems that are very good, like a camera on 4 meters high. Sorry for the meters in this case.
It's like a billion feet, right?
Yeah. So you have a very high camera, and they're very good at that level to see, okay, what are cases, what are bottles, what are shrink wrap items, and some of them are very, very good at, okay, I have my camera over here, and here's a conveyor with like a bulk of parcels, and detecting, this is a poly bag, this is a jiffy bag, this is a box.
And at 30 degrees, right?
Correct.
Yeah.
Yeah. So that's also what we benchmark and what we test. So it's for us also not that just, hey, take an AI out of the market, plug it in, and it works. No, it's always a cooperation between the two companies to say, hey, where are you good at, and can you do also this? Because that's also what we do. So not only saying, okay, this is what you can do right now, but what's your next step? And can we stretch you a little bit?
So you're trying to develop them as well.
Correct.
Bring them along for the ride.
It's a mutual development. And I always find it very nice if you have like the mutual development on, let's say, the partner side of suppliers,
yep,
but also on the other side with customers, because customers also see this technology and sometimes think, how is that even possible? I mean, like,
I thought that, yeah.
20 years ago, it's like, yeah,
you can't do that.
You can't do it. I mean, a camera was like freaking expensive. And now you see a lot of customers see that it's possible, and they also want to get engaged in that. And they say, let's do a mutual development. And then you have like a triangle with 3 parties and it complete party.
I've on a couple of occasions, I've had folks think that AI could do everything. So what are the kind of the limits of like AI vision today?
Yeah, so
What's a bridge too far?
I wouldn't say the limits of AI and vision. I think you need to look at what typically happens is somebody says, I have a person over there, I want a robot to do it.
Yeah.
And then we say, yeah, if you can spend endless money, then you would be able to do so.
Yep.
But most of the times that's not the case.
Yeah, yeah.
So then we get into the conversations like, hey, what's your data? What kind of data do you have about your product information or your processes or your throughputs or whatever? And at that time, you see people starting to think like, okay, I want to pick cases of 50 kgs or something, but I only have that once every day. So if I have that outlier there in my data, maybe I can just skip that out of the data and say,
Put that over the non-con area.
correct, yeah. And I think robots they have like a specific area where they're very good at, and everything outside of that, you should question yourself, do I really want to add it into the robot, or do I want to say, okay, I accept that the robot's gonna do everything.
Yeah, it's a juice worth the squeeze kind of conversation. Yeah,
Yeah,
a lot of times it's maybe not.
And some people believe that right away, and some people have to experience themselves.
Yeah.
And we're very happy to help them with that.
I find that when I provide a quote to the robot, and that suddenly everybody believes me. Like, oh, maybe we'll just do this one manually. Yeah. Okay, so there's kind of another hidden component to a lot of these systems, and it's everything outside the robot, right?
Yeah, right.
So we want to like connect other systems to it. It's not going to exist in a vacuum. And ideally, like in a lot of systems I design, I'd love to have an AMR deliver a pallet or take a pallet away from you and exist inside of this like fully robotic maybe environment.
Yeah.
How do you structure that communication? Like what's involved in that?
What we most of the times do is connect to a warehouse control system or something like that, where we basically feed information to that system, and that system controls the AMRs again. And of course, there's some hardware that's needed for the AMR to be able to drive in and drive out in a safe way. And I think safety is one of the most important aspects there. Like if I have a completely guarded system where the AMRs can do what they want, it's totally okay.
Yeah.
But if it's more like a standalone, then we would have to definitely have some safety communication there. But most of the times, this is over a warehouse control system or warehouse management system, whatever you like. Let's say. Yeah.
Okay, so we talked about it a whole bunch. I'd love to see what you guys brought to the show this year.
Let's do that.
Yeah, okay, cool.
Let's go over.
So what do you do when a robot has an error, right?
First, you need to detect an error. Of course, you have some force and torque guards, basically, to say, oh yeah, I have an over torque, or my position is not right.
Or else I don't feel the weight on the end of the tool.
Yeah, correct.
Does AI ever detect that?
The weight?
Well, just like a drop case. I know a lot of times I've like tried to pick up a case and the case is like fails.
Yeah.
Right? It's not the robot's fault really, but do you know that? Like
Yeah.
via AI, or are you using all like mechatronics?
No, it's basically the AI detects whenever we drop a parcel again, so it sees the same parcel, and based on, let's say, the 18 classifiers that we get out of the camera and the AI system, we can say, hey, that's the same parcel again, let's try another time, but maybe with a different pickup post. So we say, oh, maybe we pick it now from this side, it didn't work, maybe try it from this side, and maybe it works. But after 3 times, we're just like, okay, this ain't gonna work, let's skip it.
Okay.
So that's the strategy basically there.
So it's keeping track of like, I know this particular object I tried a lot of times, it's not panning out.
Yeah, correct. Yeah, correct. Maybe it's an object with like a lot of holes inside, so we cannot get a vacuum.
Yeah.
At some point in time, you need to just skip it and move on.
Yeah.
And that's also one of the strategies we use in our machines to say, okay, how can we make sure that the robot can always continue? Because at some point in time, there will be an error.
Yeah.
It's not flawless. Yeah, we just saw it a bit, but
the product's not flawless either. Like
yeah, correct.
So especially in beverage, like you could have something like leaking, you could have a missing can, you could have some of the packaging is like very delicate.
Yeah.
So yeah, it's entirely expected that something's going to go wrong.
Yeah. And you need to cater for that. So from our history of automotive, we're quite good at estimating what is, let's say, our NOK strategy. So what happens if something goes wrong? You do like the FMEAs and so those kind of things.
Yep.
And with that, you can already predict like, let's say 70 or 80% of the cases when if something goes wrong, you stop, you can sense it, and you can correct the error. You basically reset the machine and you go on. There will always be some situations which you didn't encounter. And then it's just hoping it doesn't break.
So I think that you're doing a couple of really interesting things here.
Yeah.
So the first thing I would almost classify as robotic singulation. Like you're taking an unordered mass, you're ordering it.
Yeah.
And especially for conveyor, like I was told a long time ago, presentation's everything.
Yeah.
Right. Typically, if I'm going to feed like maybe an ASRS after a robot cell, everything has to be on the left, the narrow side leading.
Yep.
I don't know, 10-inch gap, whatever it is. So
correct. Yeah.
it has to be there every time.
Yeah.
And the alternative to a robot singulator is like a mechanical singulation machine.
Yeah.
And this could be, I don't know, 50, 100 feet long sometimes.
Yeah.
Very large one, extremely expensive.
It takes quite some space to use those kind of things. And what you mostly see if you go in a brownfield situation where you have a singulation, you want to basically have on the place where the human is, you want to have a robot.
Yeah.
So and that's when these kind of machines come into play because they fit in that space.
Yeah.
So physically just being able to put something there which fits that already
got a 200-foot long. Yeah.
I mean, in some cases, those machines work.
And it's extremely high rate. You're jumping Gaylord after Gaylord. Like, yeah, that's probably the right move.
Yeah, correct. So, so different use case, different way of doing stuff, all works.
Okay.
Yeah.
Very cool. Okay, so the second thing that you're doing that I find even more impressive,
Yeah.
right, is he's grabbing them essentially randomly.
Yep.
And you're going to decide how to make a pallet based on random like presentation boxes.
Yep, correct.
It's a new pallet every time.
Yeah, it's a new box every time.
Yeah.
So basically what you see is that there's an AI system behind it which calculates what is a stable stack and what gives me the best possibilities in terms something showing up I don't expect. So there are some knobs which you can turn, stacking efficiency for instance, and that also has to do with how many sources do I have and how many destinations do I have?
Yeah.
You can imagine if you give that system possibilities, it can do a very efficient stack. So what we do here right now is one of the hardest cases because we only see the box we have over there and we need to create a stack out of it.
Yep.
But whenever in a machine concept, you could say, okay, if we know maybe 5 boxes up front and I can choose from those 5 boxes, but I also have 3 destinations.
Yeah.
So if you count the possibilities, that system can already calculate like multiple possibilities, creating the best stack.
Yeah.
An easy one is just creating towers, but creating towers afterwards, weak pallets, very weak. You cannot do anything with them.
So too close to them, they'll fall over.
Yeah, correct. So creating the interlock, basically, that's where the trick is to build a stable pallet.
Yeah.
And that's what the AI system in the stacking in this case is performing.
So sometimes when I'm like developing a system, like what's important maybe on like an ASRS discharge to a robot is what's that sequence look like? And a lot of times the main request is, can I have all the same height stuff come out?
Yeah.
But you actually don't even necessarily have that particular requirement with this.
No,
Although it would be better if I gave you all the same height.
I mean, it would be better, but then maybe this is not the right system.
Yeah, okay.
So that's where we see, like, again, the same with singulation, like with a robot or with a singulator. There are different use cases.
Yep.
And if you have all the same height, I think a layer palletizing might be the right solution.
It's nice and easy, yeah.
Nice and easy. I mean, but there are now possibilities, or there are the ways of doing stuff with this system that you can think of in your process to say, hey, if I have the palletizing process now in this way, I can think of my processes upstream in a different way.
Yeah.
So that's also what I'm very curious about and what we try to demonstrate here. Like the technology is now, let's say, industrialized, is ready to go. And what kind of concepts can you think of in a total warehouse concept where you can use this and basically be smarter in the front or cheaper in the front because this is possible?
Yeah, so like, sequencing is expensive.
Yeah, correct.
Like, getting it in the right order costs a lot of money.
Yeah.
If I don't have to do that.
No, correct.
Well, hey, I'll just crank out the pallets or in cases as fast as I can, let the robot do it. That's pretty cool.
And again, if you're going to decide to buy such a system or to use such a system, you can also use it in a brownfield because if you have if you don't have an ASRS system and then buffering is very expensive.
Yeah.
I mean, you need to create a whole system in place. But maybe with this, you can say, I don't need the ASRS system because this system can solve that problem for me.
Yeah.
So then you have, again, also in the brownfield, the opportunity to basically use the system and
But
be
he's up
smarter.
to the robot.
Yeah, correct. Yeah. Be smarter in the palletizing process. Yeah, so I'm very curious to see if you use these kind of systems and if you decide to buy one, if you might have the possibility to think around your upstream process. So not only in green fields or totally new areas, but also in the brown fields. I mean, if I now know that this process is possible, how can I think of my upstream process to change that a little? So I can
unplug a manual operation and plug a robot in.
Yeah, correct.
Maybe 1 for 1, maybe better than 1 for 1.
Yeah, maybe even better than 1 for 1. And I'm curious to see also how people like you are going to think about the warehouse concepts. And now this is possible.
Well, so one thing I think about a whole bunch is if I'm designing a super fast system, right? I might have one extremely fast like palletizer.
Yeah.
Well, that's one resource, and I don't like to have one of anything because it can break.
Yeah, correct.
But 3 robots might actually cost less
Yeah.
and one extremely fast. I mean, now I have like triple redundancy.
Yeah.
So there's a lot of that that actually kind of goes on in the background as well.
Yeah, correct. And that's also where I think the machine concept and the conversation with the customers and end customers is very important. Like, how important is this redundancy for them?
Yeah.
I mean, it's sometimes there can be processes which are not so important. There's like, I don't need redundancy. But sometimes it can be like using multiple of a smaller cell, which is more cheap, can be a better solution than using one big cell or very fast one, as you just said.
And then back in your brownfield, like you can put in one cell at a time.
Yeah.
But yeah, brownfield, typically you can't stop them.
No.
Nobody wants to
No,
stop.
no.
Once
You don't want process interruptions. No.
Yes, you pop one in and you wait and you set the second one out. Yeah, it makes it way more convenient.
Correct.
Absolutely.
Awesome.
All right. Allart, thank you very much for talking with me today. This was actually pretty fun. This display is amazing. It shows me all the things I wanted to see at the show.
Yeah.
I'm pumped about it. Thank you.
It was great talking to you. Thank you very much.
Bye.